record on this computer, so let's see. Wrong class. All right, so Sophie's here, Katie's here, she is here in a different place. Annabelle's here, Caroline's here, Harvey's here, Lily's here, Amy is not. Eva's here, Jagny's here, Kim is here, Eva is on Zoom, and Fiona's here because what would I do without Fiona? So we got that done. All right. I'm going to share my screen. We don't want to look at my email. We want to look here. All right. So today you were supposed to be looking at logs and exponents. Okay, so I guess my first question for you, as it tends to be, is are there questions on any of the checkpoints? Kim?
1.3.
1.3. All right, I actually managed to remember to, I did open this. I know I opened that one there. So there's, so what am I looking at? 1.3. 1.3. Okay. Nine. All right, so here we are, and actually Jackie and I were just talking about this one. So we need to solve this. Okay, so it is e to the 2x over what? E to the 2x plus 3 equals 1/2. Okay, so Kim, how'd you try to do it?
I don't know exactly.
Okay. So,
You can't e to the 2x become the natural log of 2x, or?
well, it can, but natural log is one of those things that you have to do to both sides of the equation.
Okay. Yeah.
So if I took the natural log of both sides of the equation, I'd have the natural log of this was equal to the natural log of 1/2, which is cool, because the natural log of 1/2 is just a number, right? I don't care. So what am I supposed to do with this, though? I mean, like, what's my goal here? What's my task?
Solve x.
To what? Solve for x, right? So what would I do now? I need to get to x, right? So I'm taking the natural log of this thing that's divided, so maybe I would use one of my log properties. Okay, so I'd have natural log e to the 2x, and then what? Minus natural log of the denominator, right? Again, natural log of 1/2, if it's a number, I don't care. So now what?
Could you separate the natural log of e?
This?
Yeah.
No, I cannot. Natural log is not an operator that distributes. Some operators distribute, right? Like multiplication. If I do a times b plus c, that's ab plus ac. Okay, but natural log doesn't work that way. So this I know how to deal with, right? What does the natural log of e to the 2x become?
2x.
2x. Okay, so that gives me something. This, like I said, is just a number that I mean, it's a number. Numbers are good. But I really can't do anything with that. So this is the situation where you have to say, okay, this didn't work. I need to try something else. Okay, so what else might you try?
Cos number 5.
What?
cross multiply.
Cross multiply. Okay, so let's see. Can I copy all of this? I copy that. And go to my page. Paste it. There we go. All right, so yeah, I would try cross multiplying. Okay, so that's going to give me 2e to the 2x is equal to e to the 2x plus 3, right? And now everything that I have, what's the word I'm looking for? Every term that has x in it is really an e to the 2x, which means I can combine them, right? So I'm going to bring this one over to the other side, but that gives me e to the 2x is equal to 3. And now what?
Wait, what did you still keep for 2 in this one?
I'm combining terms. So what am I really doing?
Oh,
when I
subtracting, right?
Yep. Okay. Those are the kinds of steps that I'm not going to do because this is calculus. Okay. That's the way it works. All right. You should, if you would like to write those steps out, you should, because I make mistakes. I'm pretty sure I didn't hear, but I make mistakes. I do algebra in my head all the time because I've been doing algebra for longer than you have been alive, way longer than you have been alive. Okay. So I make mistakes, but I was pretty sure this one I had. So now what do I do?
Use natural.
Caroline, what do I do?
Well, I did like the log property log for the 2x to the natural log of e equals the natural log of 3, and then I divided by
Okay.
x.
So I think what you did is you took the natural log of both sides.
Yeah, but
Right.
I put the 2x then in front of the natural.
I can do that. Okay. I like to look at it as, hang on, here. I like to look at it as whenever I have a natural log and an e, they undo each other, which means they kind of just become like one. Okay. So what I'm left with, and then you can do it formally, that this exponent would come down in front and then the natural log of e is 1. I'm going to take a couple shortcuts. Okay. But basically what we get is this side is 2x and the other side is the natural log of 3, which again is just a number. So that gives us x is equal to the natural log of 3 over 2. All right, we good? Okay, any other checkpoints? Dagny.
Okay, could we do literally the next, so it's example 157, it's B.
$1.37.
Yeah,
Okay, hang on.
I think it's right after checkpoint.
I think I got it now, right?
Yeah.
All right, so solve each of the following. Oh, okay. So read it to me here. I have log base 10 of,
Radical x.
okay,
plus Log base 10 of x equals 2.
okay. Anybody have any ideas? Go ahead, Dagny.
Well, okay, so because there's addition, you can actually make it into log base 10 of x times radical x.
Yep, I can. So I don't know why we have to put that little base 10 there, but
Isn't the base of the log just 10?
yeah, that's the way I would look at it, is that if it doesn't say anything, we assume it's 10.
Okay.
But this is English expression. Okay. So now what? Dagny?
Okay, so what I did is I got rid of the log by putting 10 to the second equals x times radical x.
Okay, so effectively what I'm going to do is there's no easy way to say it, but effectively I'm going to take both sides and I'm going to make it the exponent of a 10. So I'm going to make both sides 10 to the. Okay? Right? With me? Okay. And I'm going to do this in orange in honor of Mrs. Slyden, my AP calculus teacher, who liked to do things like this and say poof. She's an interesting lady. Okay. So again, those are inverse operators. They undo each other, and what I have left is the arguments. Okay. So what I have left is x radical x, because writing it the other way is driving me crazy, is equal to 10 squared. Okay, everybody follow? So we all know that x radical x is really what? X to the 3 halves. Okay, and 10 squared is really 100. Although actually, I think I might just leave it as 10 squared. Okay, and then what do I do?
Like 3.5 root it?
What, Debbie?
Would you like 3 over 2 root it? Or like?
Well, yeah. And what I do is I raise both sides to the 2/3 power, which is the same thing as a radical 3 over 2ing it. Okay, which I'm not really sure is.
I didn't think it was a thing. It
Sure,
just
that's a
sounds right.
thing. Okay. But yeah, and what I'm doing is the inverse operator for something to the 3 halves is something to the 2/3. Because those two things are going to undo each other, and I'm going to end up with x on this side, and what am I going to end up with on the other side?
21.
Well,
10
10 to the what? Let's start with that, okay?
10 to the 3 over 4
Not 10 to the 3 over 4.
of 4.
What is it?
4 over
4/3, right? Because when I take something that's raised to a power and I raise it to another power, what do? I multiply those powers, okay? So it's going to be 10 to the 4/3, which is what? Did you have it, Annabelle?
Oh, 21.544.
21.544, okay? And I think this, I'm going to say, especially because in AP Physics today, we had several conversations about sig figs and stuff, okay? The AP exam for calc just kind of uniformly says we use 3 decimal places, okay? So round appropriately and go with that. AP Physics, check the portal because I changed the date for the homework, and the lab is due later than I said, because why would we have the lab due the day before Hornet Jacket Day? And then I was going to give you another day, but I'm like, it's Hornet Jacket Day. So if I'm going to give you that, why not just give you the weekend and have it due Monday? Okay.
Yeah.
Oh, well, there we go. Okay. So like there were a million reasons why to do that. Kim,
1.31?
1.31. Checkpoint?
Yeah.
All right. Right there. So checkpoint 1.31. Okay. So
I got to where you did. I'll wait till you.
well, and we'll just start it from the beginning, okay? Because there's probably, well, just read it to me, Kim. What is it? Natural log.
Natural log of x to the third.
X to the third.
Minus 4 natural log of x equals 1.
Equals 1. Okay.
Is that right?
Okay.
Okay.
Yep. Okay. So I look at this, and it's screaming at me. Things frequently scream at me. What is it screaming at you, Frank?
You put them to the division?
I can't do that yet.
Oh.
Okay. I could do that if it was the natural log of x cubed minus the natural log of x. Then I could do that. So something else is screaming. What's screaming at you, Harvey?
Just put the 4, make it natural log of x to the 4.
Yeah. This is really an exponent, right? And if I made that into an exponent, so these were both the same format, then I could combine my logs. Okay? So that's one way to do it. Another way to do it is to deal with this cubic here and make this 3 natural log x minus 4 natural log x is equal to 1. which I think is somehow going to be, oh no, it'll be okay. Okay, so the bottom line is, I just want to put, whoops, see, I told you I was going to trip on that. I cannot figure out how to get it up, but I told you I would trip on it eventually. Here we are, it eventually. Basically, I just want to get both of these in the same format. Doesn't matter which format you choose, it will work out. That is the beauty of math, is no matter which path I take, I'm going to get to the same answer in the end. Okay, so now I can combine these again, as if my variable were natural log x. So I'm going to have negative natural log x is equal to 1, natural log x is equal to negative 1, and then I do the same thing I've been doing all along, which is what? What do I do at this point to solve for x? What?
Take the natural log of both sides?
No, I've already got the natural log of both sides. I want to do e of both sides.
Oh.
Okay? So that again, my e and my natural log on this side are going to poof. They will cancel each other out. They are inverse operators. And that will give me an x. And on the other side, I have e to the negative 1, commonly known as 1 over e. Fiona.
Could I just keep like e to the negative 1, or I should?
I don't care. When it's easy, I don't care. Like I can do that in my head. You can leave it like that, no problem. What's up, Katie?
Wait, what? No.
Really? You good?
Well, why did you put -1 as the exponent? Where does that come from?
This negative 1?
Yeah, like why wasn't it multiplied?
Because that's not what I'm doing. Because in this step, what I'm doing is I'm taking the natural log x that's on one side of the equation and the negative 1 on the other side of the equation, and I'm making them each the exponent of e. So I'm not multiplying through by anything. I'm using it as an operator. I'm using it as an instruction. And when I see an e, my instruction is I raise that e, that 2.7, whatever it is, up to that power. So, and I know that my e and my natural log cancel each other. And that gives me the x, but I still have this thing on the other side. Just like when we took the natural log of a half in one of the earlier problems, it's just a number. This is just a number. Okay? Deb.
So, okay, this is like an overarching question. So I know that you use natural logs when you use e.
Yep.
You can't use regular logs, like base 10 logs when you use e. So should we just use natural logs for everything?
Well, the reason that you use natural log in e is because e is the base of the natural log.
Mm-hmm.
Just like you use 10 when you use log log,
Yeah.
because that's the base of that system. If it was log base 2, I would use it too. We generally use either natural log or log base 10. In many situations, especially now, you can use either one, and you will be able to get to the answer. However, when we get to actually doing calculus, you're going to want to use e and natural log. So I would get into the habit of doing it now, especially if you're like, natural log. Because yes, you're going to have to do, because if you don't, you're going to have to use the change of base formula every time you choose to use a base 10 log if you want to do that. Okay. All right, you good? I mean, we can finally get to the fun activity. I've been planning fun activities for 2 weeks and y'all have too many questions. I love questions. Questions are good, but I have invested time. Oh, Eva.
I think it's quick. I think I'm just not understanding a small thing.
Okay.
Okay, so number 20 is example 1.38.
All right, hang on.
1.38.
Do I keep going? Oh, this is going to do this thing. Let's see. So that's 1.7, 1.37, 1.38, change of base.
I just don't understand why you use natural log. Like this.
Because that's the change of base formula.
That's it.
I mean, that's the bottom line.
Okay.
is that that is the formula that we use for change of base, which may have been up above. Where's the change of base formula? Here, right? The change of base formula that says log base A of x is equal to the natural log of x over the natural log of A. That is just a thing. That is the way it works. There's a proof. I don't need you to know the proof, but that is how it works. Annabelle.
You could do log 7 over log 3 or like,
For 1.38?
yeah, well,
No,
no.
you can't.
But in the next question, it's like ln 6 over ln 4, and I did log 6 over log 4 and
Well,
maybe I'm 8.
well, here. Okay, so if the change of base formula says it's log A base x, and that's going to be the natural log of x, or the natural log of A, right? Right, that's the formula. Can you check for me? Okay, so if you're doing it with a number, is that the right number? Log base 37. Okay, so that means this is going to be natural log of 7 over natural log of 3. Okay. And you're saying that this is equivalent to the log of 7 over the log of 3?
I was asking, yeah, it does work out.
I think it has to do with the fact, that it's because it's actual numbers. And so what I'm doing is I'm multiplying 7 of something. I'm sorry, I'm taking 7 of something and dividing it by 3 of that same thing. So it doesn't matter what that thing is, because the thing itself is going to cancel. And what really matters is what the ratio of 7 and 3 is. I'm not saying that this is equal to 7/3. I'm just saying that what you're doing is you're kind of taking the same number of things in the top and the bottom. And so it doesn't matter what that thing is, the ratio is going to be preserved, whether they're apples or oranges or rhinoceroses or E's or 10s. Okay, so I think that's why this works.
Okay.
I'm not sure, and I do remember as I was going through and doing the checkpoints, thinking about this at one point, and I think I actually calculated it both ways. But I would go with this. Again, because what's more likely is you're going to have an expression. It's going to be log base 3 of x squared plus 8. And you're going to want to have it this way for what we're going to be doing in terms of taking derivatives and integrating. Okay? All right. Are we good? Okay, then let's do the activity, because what time's class over? 1:25? What is it?
35.
35, all right, we can try. Okay, so if you go to the collaboration space, and I added in my, my BC folks, okay, so that you can be in here. Okay, so the way this works is you will, except that you can't see it. Okay, there are different documents up here. They're all identical, but you have to go in the right one. Okay, so in each document, there are 3 sets of problems. Okay, and what you do is everybody in your group, so you have at least 4 people in your group. Amy's not here, so there's 5 people in hers, so we don't have to worry about Amy. Okay, with your group, so whether you have to Zoom or talk or do whatever, okay, you're each going to do a different problem. Your problems have a numerical answer. You are going to add up your numerical answers, and they should be equal to the thing in the middle. If they don't add up to the thing in the middle, then somebody made a mistake, and you have to figure out who made the mistake. Okay, and if you get through the first one, and we still have time, because you said it's 1:35, this one class ends, so we've got about 11, 12 minutes before we have to start cleaning things up. So then go to the next step. Okay, so I would figure it out and make sure that you write the name of the person that's doing each one somewhere in that quadrant. It would be good if you did your work in there so I can see it. Dagny.
With Amy, should we like leave the space?
No, because there's 4 problems to do, but I think I figured out this was an afternoon class and Amy wouldn't be here. So she can, do what she wants on her own, but. Okay? Go to, it's in the collaboration space, and then the pages just have your names on them. Okay?
Can I put that into the
No. I mean, you can do it later. You can make a copy of it later, but no, because if you put it there, then your AB friends can't work with you. And that's the only, my BC people, that's the only thing you should be doing in the BC notebook, in the AB notebook, excuse me, is the collaboration space stuff. I'm not going to look for any of your other stuff there. Okay? So go. Be free. No, don't be free, but
All right.
figure out who's going to do what.
You gotta do those for
You can do that. We just have to make sure that we spread out.
Okay, how about we just go in the order of names? So like Annabelle, Caroline, myself. Do we have to like do the set? So I'm doing 2. Yeah. You're doing this one. Wait, so Harvey, I'm doing the -4 long time. Yes. What? Oh, can we just like talk to her right there real quick? Sure, go ahead. Okay. Wait, I have to do it? Yeah. Okay, what do I say? Wait, so are we just doing like, I mean, that? Yeah. Sure. Wait, so like, oh, sorry. So wait, Tia, are you doing one on the left or the right?
I could do either, but
I mean, I don't know how to do either, so you can choose. Okay, where's, okay.
Hi.
Oh, I'm on mute. Oh, I can't touch your computer.
Well, then go on that computer.
Well, it's okay.
Yeah, no, stand, just, yeah.
oh god, that's this one.
I have the easiest one and I don't know how to do it.
Are you kidding?
Just go.
Oh my God, just stand at her computer, don't touch it.
Well, because it's on mute. Wait, press down the seat for it like that. Or Katie, do the paper towel.
Or
like the paper
if
towel.
you want,
Okay.
I can tell you that.
Oh, yeah. That'll do.
That'll do it.
Well, we wrote her name on the one she's doing.
Okay.
Just tell her what we'll do.
Oh, I don't know my computer does. I don't know what I'm doing.
I don't know what, like, genuinely, I don't know how to do it.
Oh, just solve it with log. So you do, because then the x goes in front of the log, so it's x log 25 equals log.
And I still have one.
So then
Equals log, that.
Yeah. And then you solve it.
By log 5.
yeah, solve it with your calculator.
Why does everything keep showing up after I did this?
I got 6. I don't know if that's right.
Okay,
You did? For like the bottom left corner? I'm genuinely surprised I got that right.
quadrant 2.
So put this stuff, shouldn't we put it all in before? If you make that a log, you can, I guess.
Wait, but it doesn't have a base of 10, so I can't do it. You know what I'm saying? Because it's long base of 8.
All right, so do you guys need to Zoom with Yvette, or are you talking to her in the, what?
We like wrote down the names in our group.
Oh no.
Yeah. I just have to write it up. I'm thinking about that. What if you guys might come out now? You're right. I Oh, can you just put it in? I'm gonna do the change base.
Yeah.
I can't.
X equals.
Base of.
Oh, no, you can't.
Wait, so
That's what I'm saying.
there.
No, yeah, you figured it out.
How do you plug in from base up?
Wait, I think I wrote it out.
It's in second, when, or no, also when there was like. What?
Bro.
The other half, take that.
Oh, wait.
That's it.
Okay, I got X equals 4, then I have to do log 8 for, but then I can't just like log add that.
Yeah, if you have X equals 4, then we'll be the.
Did you guys go ahead and grade?
Yeah, you got.
Where's my grade? Could I grade everything?
Yeah.
Okay, I got 4.
You want to?
I got 6.
Yeah. Or do you want to just do the same quadrant for different?
Yeah.
Yeah, what did you,
How do you
wait,
do that?
Annabelle, what did you get?
Yeah.
Okay.
But
Because if
Dr. Goetz.
Caroline and I makes
Yeah, you
sense,
got that already.
and then Fiona's is 4.5.
is there what?
That makes 14.5.
Change the base.
Probably 0.001.
Yes, the change of baseline.
So you can use the.
Wait, so Fiona, that's just the change of base?
I'm
How
fine.
far is that?
Yeah, my way of us are done.
Okay.
And the 3 of us adds 14.5. And we're looking at 14.5.
Okay, I did
done that one.
Yours line, and Annabelle could give me help because I figure out how to do that.
Yeah, that's the law of. He's so
So I did.
What?
Oh,
Oh, sorry, yeah.
I'll show you I did.
Okay. Wait, here.
Okay, so this is what I did. I did 540.
What mode does that, does this calculator?
Oh, yeah.
Wait, what, thank you for logs, for the first one? No, we're. Oh, yeah, that's long.
It should be equal to 0, 1.
Yeah. Did you get point 0, 0, 1 there?
Yeah. Does it add up?
Yeah.
Okay, so you guys already had 14.5.
Yeah.
Yeah.
Okay, so next one.
Yay.
Do we want to switch corners or no?
Can we just stick to them?
Yeah. Okay. I have the easiest corner, so yes.
Why do I think of this one?
So did that know to do that?
All right, so how'd we do?
We got
The first one correct.
We got the first one.
Excellent. Try another one. We still get it. We still got a couple minutes.
Yeah.
Like, Eva, did you see yours with the calculator?
I did. I don't think we're supposed to, but I in fact did.
That's another way to do it, but I can't remember.
What do you think? You said it?
The second, like, round around the fourth quadrant.
Log of 6 over 22.
Yeah.
Isn't that just the natural log of 22 over the natural log of 6?
Or just do something else.
Oh.
Okay, so I got the answer.
What am I supposed to do? I'm like, oh, I'm like, I'm good. For yours, I think you can set it equal to X and then do like the even thing. And then you go through. You know what I'm talking about?
Yeah, very much.
Yeah, your key.
I never looked at either.
Oh, so set it equal to X and then.
Well, I already solved.
What?
I already solved.
Oh,
Well, I put it in the calculator for you.
I'm trying to tell you how to do it.
Okay.
Okay, so you go from the 6 to the X to the 6 to the X. You're like, can you help yours?
Yeah.
I'm trying to figure out.
I don't know if I can do it.
Yeah, I'm trying to figure out yours as well.
I'm just getting actually funny too.
Yeah, but then I don't know the log.
So, this is what I got so far.
Then we'll.
Oh, yeah.
Then it'd be like x log, whatever I said, equals log 22. I think, I could be very wrong.
I believe you. Caroline, which one do you have? I'm on the second, like the one with this one, second quadrant. Actually, okay, think of a quadrant 1 on the graph. Okay, yeah, that's one I'm
If you might, wait. If you make them both natural logs. Oh, yeah.
All right, how we doing?
Not
So
good.
can you do the natural log of both sides?
Yeah, so I did the natural log.
All right, we got 1 minute, and then we got to start cleaning stuff up.
Caroline, I might have something, but I'm not sure if it's right.
Which one are you trying to do?
The log of
Or,
you did that by negative.
So for the third, second, fourth quadrant, they're all the same.
So you multiply this, right? So you got.
Can you put that in your calculator?
I ended up doing that. Yeah, that's why I got, okay.
And then subtract the 8 and divide the 8.
Yeah, that's what I did. I'm not gonna go work, I got a negative number, which I'm not sure.
Yeah, did you get negative 8.9?
I got negative 0.8.
Or negative 0.819?
And yeah, that's what I got.
Yes.
Okay.
You said negative 8.4.
Oh, sorry.
You're good, just making sure.
So
Okay, also,
negative
find out
495.
And then I'll let you know.
Okay.
Okay. I'll let you know.
We all have our answers.
It was actually equal to natural log of e to the 4. What would it have to be?
Whoever had quadrant 4, is that one negative? Fiona. Well, is your answer negative?
No, it's.
No. Okay.
It's.
No. They just cancel out when you get whatever that exponent. You guys should start cleaning up. So,
Guys, we got the right answer.
Yeah, we did it?
Yeah, we did.
so start packing stuff up.
Oh, yeah, we got it.
Okay, make sure you spritz, especially if you move desks, make sure you spritz twice. Yvette? Thanks for joining us, Yvette. We'll see you tomorrow morning, okay?
Bye.
Bye.